Welcome to the Demonstrating Implementation Excellence stream of SNOMED CT Expo 2023. My name is Nick Egerhaus. I'm the Global Vendor Engagement Lead and Customer Relations Executive for the Middle East and Africa at SNOMED International. I'll be moderating today's session. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A button to type your questions to the presenter. And on-site attendees, please use the microphone provided in the room, right in the middle there. I'm now pleased to introduce Dr. Dominique Pham from FAST, who will be presenting Building and Delivering Knowledge Artifacts of Drug Contraindication. Dominique, please go ahead.
Hello, thank you for your introduction. Yes, I'm Dominique Pham. I'm a clinical semantic lead at FAST, an interoperability provider based in France. And during this presentation, I'll share with you how we made this knowledge artifact using reference terminologies and FHIR-like resources. I'll start by giving you a brief overview of what we do at FAST, and then I'll delve into the semantic and syntactic standards we use to create this knowledge artifact and our goal to meet the European scalability requirements. And then I'll share some findings and some challenges we encountered, and I'll finish with our perspectives for the future. So at FAST, one of our main activity evolves around an interoperable metathesaurus of drugs. So what we do is we provide medication information sourced from official health bodies in a standardized manner to support semantic interoperability in clinical drug-related workflows. This data is distributed to healthcare institutions and can be used by various computer applications involved in the medication process. Lately, we enhanced our metathesaurus by including the clinical characteristics of drugs, starting with contraindications. So these were converted from text to a machine-readable format using SNOMED and LOINC, so that clinical decision support services can use them to align medication prescriptions with patients' clinical conditions. So this slide describes the transformation process from the narrative of the summary of product characteristics into a structured form coded with clinical concepts coded in SNOMED and LOINC. It was a three-layered process. First, the text was cut into standalone clinical situations. And then within each situation, clinical concepts were isolated and logically linked using Boolean operators. And finally, the structured data was enriched with the clinical concepts coded in SNOMED and LOINC. So now let's have a closer look of the content of contraindications. So these fall into distinctive categories. One of them is the patient-specific contraindications. So whether it's a specific age group or population category, and you can see an example here on the right side of the slide. Another type of contraindications is any health-related contraindications. And these include any medical conditions or interventions. There's the allergy and hypersensitivity type of contraindications. And finally, we have the route-specific contraindications. So while keeping these categories in mind, let's see how we modelized our structured data. So we built our concept model around SNOMED CT's concept model using its compositional grammar. We can think of our model as starting with the administration of medication as the core concept. And when we discuss contraindications, the administration of medication is contraindicated. So starting with this core concept of administration of medication, we are able to represent the different types of contraindications by adding various attributes in order to describe many of the criteria encountered in contraindications. And these attributes include the recipient category, which allows us to specify an age group, but also a population category or a subgroup or a demographic information. We also added here a LOINC concept to represent quantitative observations like age. The has focus attribute can be assigned any clinical findings as a value, and we also added a LOINC concept here to represent any measurable observation. It can also be assigned any procedures. Also for allergies and hypersensitivities, they can also be described using the has focus attribute. And finally, for the route of administration, the route of administration attribute allows us to define route-specific contraindications. So we looked at all these categories of contraindications and these attributes that help describe them in our concept model. Now let's dive into a higher level of complexity in the concept of contraindications through one example. So here we have HIV/HCV patients with cirrhosis and a Child-Pugh score greater or equal to 6, except if only due to indirect hyperbilirubinemia caused by medicinal products such as atazanavir and indinavir. So this is how we modelized this contraindication. So the first concept is HIV/HCV patients with cirrhosis of liver. And we used here the AND Boolean operator. A LOINC concept for total Child-Pugh score. Here was greater or equal to 6, except, and we used the not Boolean operator, if only due to indirect hyperbilirubinemia caused by medicinal products such as atazanavir, and, which actually means or in this case, indinavir. Now, to support our concept model, our starting point was the FHIR clinical use definition resource. This resource includes metadata identification and also the population group to which it applies. The contraindication element specifies a symptom. So the situation documented as contraindicating the drug, the status of the symptom, if it's chronic or metastatic, and comorbidity. And so we were limited in representing complex conditions like Boolean logic, especially the not Boolean operator, or we were limited in representing certain context, like specifying a status to a specific comorbidity. So as this resource was not sufficient to fully express our contraindications in a computable way, we derived this model to create a FHIR-like resource that we named the Fast Clinical Use Definition. And inside it, we find several similar elements with the FHIR Clinical Use Definition resource. So the Fast Clinical Use Definition resource also encompasses metadata, but the population was taken out in order to add Boolean logic and also allow associations between qualitative and quantitative population characteristics. We also added a criterion element, which is linked to the contraindication element to enable Boolean logic in the model. And this criterion element holds all the health-related elements, so any procedures, any clinical findings, or quantitative observations, as well as allergies and route of administration. So if you look closely within each element, post-coordination was broken down, and all defining relationships with their attribute used within a post-coordinate expression are here delivered individually to simplify implementation. And also for the allergy and hypersensitivity element, in addition to an attribute that states a pre-coordinated concept, there's systematically a causative agent attribute. So what causes the allergy or the hypersensitivity? So this attribute is always stated, and it's again to simplify implementation to the broader community. So now this metathesaurus of drugs covers 13,000 specialties. It documents 4,000 contraindications, which represents more than 5,000 expressions translated in SNOMED and LINQ. Through this process, 65 new concepts were added to the international edition, and it's been in distribution since May 2023. And on the right side of the slide, you can see a screenshot of the CIODC Metathesaurus viewer. Some of the limits we encountered looking through the narratives of summary of product characteristics was dealing with semantic ambiguity. And here's one concept to illustrate this. The concept non-valvular atrial fibrillation. So the term non-valvular suggests that atrial fibrillation in this context is not associated with any heart valve disease, but it's actually not the case. Non-valvular atrial fibrillation actually includes atrial fibrillation with native valvular stenosis and insufficiencies, as well as patients after mitral valve repair or bioprosthetic valve replacements. And so, sorry, I forgot to show you the structured data. So it's not this. Non-valvular atrial fibrillation actually refers to atrial fibrillation in the absence of two specific valvular findings. So a mechanical prosthetic heart valve or a moderate to severe mitral stenosis. We also faced challenges in expressing abstract concepts, for example, a symptomatic bradycardia. So the term symptomatic can actually not be used as an attribute to describe the bradycardia because it does not follow the modeling rules. But also the term doesn't provide specific details about the nature or the severity of the symptoms. So there could be many different ways to translate this in SNOMED. It might be equivalent to a moderate to severe bradycardia, or it could be interpreted as a significant bradycardia. And like in all translation process, there can be a loss of information. Other limits were dealing with structural complexity. And right now, our model does not support expressions such as quantitative measurement with a temporal context, but it's still an ongoing work. Also, post coordination with nested expressions, like for expressing specific context alongside other many attributes. These can represent a set of challenges in terms of implementability. So now for the perspectives, the contraindications knowledge artifact is in distribution in France. We plan to contribute to HL7 working groups and share our experience, as our deployment for this knowledge artifact in Europe is scheduled for 2024. At the time, we're working on the knowledge artifact for indications, which is currently undergoing a validation process. And our future plans include addressing interactions and dosages. Our long-range goal being to produce a clinical knowledge artifact covering multiple domains. Thank you very much for your attention. I want to give a big thanks to my fellow co-authors and all the people involved in this work. And now I'll leave the floor for any questions. Thank you.
Thank you. And Dominique will now take questions. She also has, applause. She also has some other team mates on the line right now. Emily Nguyen, head of CIO DC unit, Louis Billet, head of TIO unit, and Michelle Blondel, IT director. Any questions? Anyone in the room? Oh, there's one online here. From Colin McFarlane. Since the resource goes beyond the current scope of FIRE, to what extent has the model been implemented?
I think.
Are they getting this, Michael?
Yeah.
Yeah.
I think maybe Michelle, my colleague, who's the IT director, will be able to give more details on this.
Can we unmute Louis?
Hello.
Oh, Michelle is unmuted. Louis, yep, there you
I think that's for Michelle.
Ah.
Yes. Can you hear me?
Yes.
Yes.
Yeah, okay. Currently, the resource from Fire is not very the resource we need. We need to work on an evolution on this resource before being able to add some extents to this resource. I think the major problem is the Boolean expression we don't have in the R5 clinical use definition. Does it answer to the question?
Okay. I think so.
Yeah.
Not seeing anything else online. Thank you, Michelle. We have a question in the room here. Just use the microphone.
Yeah, thank you for your presentation. It seems like a great resource that you've making there, that you've made there. Is what steps are you planning for, let's say, medical record vendors to implement the resource and to use it in their clinical practice, to integrate it in their workflows?
I'm sorry, can you repeat starting?
Can you move the microphone up so that you can speak into the
Sorry,
microphone?
can you understand me better like this?
Yeah, perfect. Thank
Okay,
you.
so great work, great resource that you've built. And my question was, what are the plans to implement this in medical records, and how do you, how do you see this, to create uptake in the medical record that they use it to actually check contraindications and stuff, that to make the resource used in day-to-day practice?
Yeah, so I think the question is how are we gonna use this knowledge artifact? Is that am I understanding your question right?
Yes, that's the question. Yeah.
Yeah, sorry. Well, so we in FAST we work to provide knowledge artifacts. So we're not a clinical decision support. We don't provide. We're not a clinical decision support service. We are advocates of cementing interoperability, and we focus on providing this knowledge artifact based on SNOMED. But yeah, we are very interested in seeing how this knowledge artifact can be used within a clinical workflow. But yeah, our activities is to provide this knowledge artifact. But after, for the usage within medical records, it's something that we look forward to see, and how it can be used, and but yeah, we're not a clinical decision support service. So yeah, hopefully I answered your question.
Good. Yep, I think you did. Thank you very much.
Thank you.
Anyone else in the room or online? Well, I think with that, we'll call an end to the session. Thank you, Anne, Dominique, and team. Online delegates can join another session through the event lobby. Thanks again.
Thank you.